Good day, everyone. Today we are talking about section 6.1, add, subtract, or multiply polynomials. Several learning targets today. I can identify if an expression is a polynomial, and if it is, then we can identify the degree, the leading coefficient, and write it in standard form. Once we are working with polynomials, we're going to add them, we're going to subtract them, we're going to multiply by a monomial and a binomial. So first we're going to start with identifying or defining what is a polynomial. A polynomial is an expression consisting of variables and coefficients operations, and these are limited to add, subtract, and multiply, and whole number exponents. Basically, what it comes down to is, yeah, the coefficients and variables, those are things we've seen and talked about before. The big thing is its whole number exponents is the big thing with what makes a polynomial. When we talk about polynomials, we can classify by the number of terms. So a monomial, let me just pull this down here a little bit. So a monomial, mono, the prefix meaning one, is a one-term polynomial. So an example of that would be 3x squared. So that's an example of a monomial. Bi is the prefix meaning two, so a binomial is a two-term polynomial. So an example could be 7x to the fourth minus 5x squared. Again, I have whole number exponents, I have variables, I can have coefficients, I don't have to. And again, my operations are add, subtract, and multiply only. All right, our last one here, trinomial. Again, the prefix tri means three, so it means this is a three-term polynomial. Which is what we're going to work with most in this chapter. So you'd have 4x squared plus 3x minus 2 would be an example of a three-term polynomial. If there are more than three terms, we just default back to the term, or the term polynomial. So if there are four terms, we just say it's a four-term polynomial, or five-term polynomial, or whatever. All right, when we are working with polynomials, we are going to write them in what is called standard form. You've heard me use the term standard form before. We're talking about exponents. Again, we talked about it was in alphabetical order, numbers in the front, so we call those numbers the coefficients, and then variables in alphabetical order. That's part of standard form. Part of it is when we are writing polynomials is you have the largest exponent first and then the smallest last. So we're going to say it's written from largest exponent to smallest, which would be the constant term. We're talking about constant term, that's the term without a variable. So like if there's a plus, so like on this one here with the trinomial, this minus 2 at the end, that's what we call a constant term. It's negative 2x to the 0 power, and as we know, the zero exponent property says it's equal to 1, and so we just don't write when the exponent is 0. Degree is the largest exponent. And so when you rewrite it in standard form, the largest exponent goes first. So the degree is basically the exponent of the first term. The leading coefficient, leading meaning out front, coefficient meaning number, is the number in front of the first term. Now, this also does need to be written in standard form. So we'll say when written in standard form. So yeah, I use the largest exponent to rewrite it in standard form, and once I have it rewritten in standard form, whatever number's out front is our leading coefficient. It's not going to make a huge difference for us, but when you get into Algebra 2 stuff, the leading coefficient does have some properties that you would know. If you think back to when we did absolute value graphs, we had that A value that was written or implied out front. That would have been our leading coefficient. All right, so in this problem, we are asked to rewrite each polynomial in standard form and then identify each term. So to rewrite it in standard form, find our largest exponent, which in this case is the 4 here. So we are going to rewrite 2x to the 4th. And again, I'm going to cross the term off once I've used it. The sign goes with the coefficient that follows. So this is positive 2x to the 4th minus 4x plus 7. So that is rewriting it. All you do is go from largest exponent to smallest. And again, whatever term is constant with no variable always goes last. The degree, what's our largest exponent? 4. Again, it's our first term. Leading coefficient, what's the number out front? 2. Classify, how many terms are there? 1, 2, 3 makes it a trinomial. And that's all that there is to doing these. So I'd like you to pause the video and try each of the next two on your own. All right, so on the middle one, you should have had 8x to the 3rd minus 4x squared plus 5x plus 13. Again, the sign goes with the coefficient or that number that follows it. So the degree, largest exponent is 3. The term when it's written out, or the coefficient out front when it's in standard form is 8. And there are 1, 2, 3, 4 terms. We just say 4-term polynomial, or actually you could just write polynomial at that point. The last one, again, this negative is attached to the 7, so it's negative 7y to the 5th plus 4y to the 4th plus 2y. Largest exponent is 5. Negative 7 is the number out front. There are 1, 2, 3 terms, so that makes this a trinomial. What we can also do with these is we're going to be given some type of an expression and they're going to ask you, is this a polynomial? Determine if the expression is a polynomial. So it's kind of a yes or no question. If it is, so this is kind of the yes results, classify it by the number of terms, so mono, bi, tri, or polynomial, and then the degree. What is the degree? What is the largest exponent? If it's not a polynomial, so this is if you have a no response, why is it not a polynomial? So the first one, negative 6. Is this a polynomial? It sure is. Classify it, well, the degree would be 0, because again, this could be negative 6 times x to the 0. Your constant terms are always a degree 0. There's no exponent there. There's only one term, so that makes it a monomial. Now, again, so you come back to what is our definition of polynomial? The big part is that it has whole number exponents. So when I look at this next example, I can see right here that I have an exponent that's a negative. Well, that's a no-go. So because it has a negative exponent, it is not a whole number. Again, whole numbers would be 0, 1, 2, 3, 4, 5. Whole numbers are like the counting numbers plus 0. So it is not, and why? It cannot have a negative exponent. So I would like you to go through, pause the video, and try each of the next 5 on your own. All right, so the green one, yes, again, has whole number exponents. So yes, there are, oh, sorry, I made a mistake on that. The largest exponent is 3, so it should be degree 3. And then 2 terms, so makes it a binomial. The blue one here, yes. I mean, again, this would be an x to the 1 there. So yes, it is. The largest exponent is 4. 3 terms makes it a trinomial. The red one here, we have a variable exponent. That's a no-go, so that's not a polynomial because of the variable. The second to last one, all whole number exponents. Again, if it's not written there, it's implied to be 1. Degree 7, 3 terms makes it a trinomial. And again, the last one, we have that negative exponent, so that is not a whole number, so it is not a polynomial. All right, now that we know what a polynomial is, we're going to talk about adding and subtracting them. One method is like when we did collecting like terms, where you would say, oh, here's like terms, there's like terms, and those are like terms. We did this back in like chapter 1, I believe, where we talked about simplifying expressions, and we said, okay, these are like terms, we add them together. That is one method of doing this, and that's a valid method. The problem is when we get to subtracting, you can't just collect like terms because it's not an adding problem. So what we need to do then is we need another method. So I'm going to show you what's called the stack method. And what I'm going to do is I'm going to rewrite the first problem. So 3z squared plus z minus 4. And then what I'm going to do is I'm going to stack the second polynomial, 2z squared plus 2z minus 3, underneath it. I'm going to put a plus out front because I'm adding them together. And now when I add them, I'm just adding each column. And what's nice about this is I do not need to carry over. If I get more than 10 of something, I just write, okay, I've got 12 of these. It's not a big deal. So 3z squared plus 2z squared. Again, when I'm adding, the variable part does not change. So I'm just adding the coefficients. So 3 plus 2 would be 5 z squareds. And I have here, again, if the number is not written, it's implied to be 1. So I have 1z plus 2z, 3z. Negative 4 plus negative 3 is negative 7. All right, I'd like you to pause the video and try the next one on your own. All right, so we rewrote 2x squared plus 5x minus 1 plus, and then we stacked that second one underneath. So you had x squared minus 5x plus 7. And we add 2x squared, again, implied 1, so 2 plus 1 would be 3x squared. 5 plus negative 5 is 0, so essentially those cancel each other out. Negative 1 plus 7 would be 6, so that would be your solution. Now, when it comes to subtracting, we're going to go back to a definition that we used the very first section here in saying that subtraction is adding the opposite. So that's what we're going to do. We're going to add the opposite. So on our first example, again, when you do this, you're going to copy the first problem over. So 10b squared minus 3b plus 2. And essentially, it's like we're distributing the negative, if you will. But we are going to write the opposite of everything that is in that second polynomial. And again, we're going to change this to an adding problem. So you're going to have 10b squared plus negative 4. Again, the b squareds aren't going to change. So just 10 plus negative 4. Negative 3 plus negative 5 would be negative 8b. 2 plus negative 1, or in other words, 2 minus 1, would be positive 1. Now, on this last one, it's a bit of a little bit different in that these are not perfectly matched. Again, you are still going to copy the first one. Again, always in standard form. Sometimes you'll get these are mixed up. They're not in standard form. So you always rewrite the first one in standard form. When I'm doing the second one, I'm always matching like terms in the same column. The fact that there's not an m squared, it's just like a 0. So I could say there is 0m squared if I wanted as a placeholder, but I wouldn't have to in this case. So when I go negative 4m squared plus, there's nothing to add it, so it's going to stay the same. Again, implied 1, so 3 plus negative 1 would be 2m. Negative 1 plus negative 2 would be negative 3. Make sure when you are doing the stack method that you put like terms in the same column. And when we come to class, we will do a bunch of these. So it's important that we are getting these right. All right, this also has some geometry applications. So when you're trying to find the perimeter, we all know that the perimeter is you add up all the sides. So when we have some type of an expression like this, we can use the stack method to add up all the sides. Now, on this one, when doing these, I recommend doing something to show where you are starting. So I'm just going to draw a little mark. I'm drawing a little stick figure here. You do whatever you want. You can put a little star or whatever. And so we're going to say that the perimeters add up all the sides. So the first side is 2x plus 1, and then it's 3x, and then we have another 2x plus 1, and another 3x. And I'm going to make a stack and add the entire stack. So I look over here on the right, I got 1 plus 1. Well, that's just 2. 2x plus 3x plus 2x plus 3x is 10x. So the perimeter is 10x plus 2. Doesn't matter if we have quadrilaterals or triangles, anything like that. Any geometric shape, we can simply add up all the sides. So I'd like you to pause the video and find the perimeter of each of these two. All right, so on the first one, you should have gotten 9x minus 1 for the perimeter, and the last one, 4x plus 4. All right, the next term, multiplying a polynomial by a monomial. A monomial we know is one term, so that means there's going to be one term on the outside. You've done these problems before. These are distributing problems. If you need to draw the rainbow arcs, draw the rainbow arcs. Again, there's no number out front, it's 1. So here we're going 1x squared times 6x squared. 1 times 6 is 6. X squared times x squared. Again, you are going to add those exponents. This would be an example of the product property. X squared times negative 3x. So we're going 1 times negative 3. X squared times x to the first would be x to the third. The last one, we've got 1 times negative 1, x squared, and then there's no x terms here, so it's just going to be negative 1x squared. If I wanted to think about it, I could think there's an x to the 0 there. Again, why would we write it? There's no reason to, but we're adding those exponents, so it's 2 plus 0. So it's x to the second power. That is your answer. So there are a few more on here, so I'd like you to pause the video and try each of these on your own. And so you can check your answers against mine. The top right would be negative 28 to the 7th plus 15a to the 4th minus 5a to the 3rd. The bottom left, negative 8d to the 5th plus 20d to the 4th minus 24d to the 3rd plus 8d squared. And the last one, 6y to the 4th plus 2y to the 3rd minus 8y. So you've done distributing before. We're really adding just that exponent part of it now. And that's going to lead us into multiplying two binomials. Again, binomial has two terms, so we're talking multiplying a two-term by another two-term. Now, there are 4 different methods that I'm going to show you. You do not have to know how to do each of these 4. You just need to know how to do one of them that works for you. I would like you to take notes on all 4 because you may find that after you try doing one, you're like, I don't know if this is really my best method. Maybe I want to try that other method. So please take the notes on all 4 and then decide, maybe you try a couple and decide which one you like the best. So the first method is the tried and true method. This is the method that I was taught. This is the method your parents were taught. And that is FOIL, which stands for first, outer, inner, last. So when you are doing first, you are going to multiply the first term of each parenthesis. So that's 3x and 2x. So you're going to get 6x squared. Outer, you're multiplying the outermost term. So this would be 3x times and then negative 5. And so we get negative 15x. Inner, I'm multiplying the innermost terms. So that is 1 and 2x. And I get positive 2x. The last, I'm multiplying the last terms. So this would be 1 and negative 5. If you are choosing to do FOIL, you don't have to write out first, outer, inner, last. You definitely don't have to do like this line here I'm underlining. You do not have to do that. You would do the work below that yellow line. So 6x squared minus 15x plus 2x minus 5. Now, we do have some common terms here, some like terms, so we do have to add those together. So we're going to get 6x squared, negative 15 plus 2x would be negative 13x minus 5. This would be your answer. All right, now we're going to do the same problem using what's called split distribution. This one is a very popular method. When I am splitting, what's going to happen is I'm literally going to take that parenthesis, I'm going to split it in between the two terms. So I'm going to say this is 3x, and I'm going to copy the second parenthesis, 2x minus 5. And then I had plus 1 and 2x minus 5. So I split the first parenthesis into two parts. There's the 3x part and the plus 1 part. And now this is just a distributing problem. We just talked about distributing, so I'm going to distribute. So you get 6x squared minus 15x plus 2x and minus 5. You will notice that these two lines are the same. All of these methods do the same thing. It's just how do we organize our work? How do we organize our thoughts? And again, we have like terms that we need to collect. So we're going to do that. And we get the same answer, 6x squared minus 13x minus 5. Spoiler alert, we're going to get the same answer when we do these two methods too. All right, the area method is probably my favorite method. But like I said, I'm showing you all four. You use the method that works for you. So in the area method, what's going to happen is we're going to draw a box. And then each term gets its own column or row. So since it's 2 terms by 2 terms, we're going to have 2 by 2. And so we are going to put one of the polynomials, or I'm sorry, one of the binomials on top. I'm going to do 2x and minus 5. Notice the minus is with the 5. And then 3x plus 1. I'll be honest with you, it doesn't matter. You could put 3x plus 1 on top and 2x minus 5 on the side. That part doesn't matter. Now, to fill in the box, what you're going to do is, like if I'm looking at this box right here, I'm saying what side, where's the column? Well, 2x, and the row would be 3x. So I'm going to multiply those together and get 6x squared. Well, to do this box right here is negative 5 and 3x. Well, that's negative 15x. And I'm going to continue. This box, well, that's 1 and 2x. So that's 2x. And then my last box, well, that's negative 5 and 1. So that's going to be negative 5. What's nice about it, it doesn't matter what order I multiply. Now, when I go to do my final answer, I'm going to start on the top left corner. So in this red box, the top left corner is always going to be by itself. My like terms are always going to be diagonally. So here, negative 15x and 2x. And like always, when we're combining like terms, we are adding these together. And then, so I'm going to keep working diagonally, and My last term, my constant term is always going to be in my bottom right corner is -5. What I personally like about the area method is if we had a bigger polynomial, say we had 3 terms or 4 terms, we just draw more boxes. All right, the last one is the stack method. You may remember when you were younger learning how to do longhand multiplication. Say you had to do 128 times 37 and you couldn't use a calculator. And so you would go, okay, 8 times 7 is 56. We put the 6, carry the 5. And for some of you, this is bringing back nightmares already. This is the concept of the stack method, okay? So what's going to happen is we are going to rewrite these one on top of the other, just like we did with the adding and the multiplying, or like adding and subtracting. It doesn't matter which one you put on top and which one you put on bottom. When we get into section 2, we'll talk about it, then it does make a difference. But if they're both binomials, it doesn't matter. So I chose to put 2x minus 5 on top just because that's the one I wrote first. Just like here where you did 8 times 7, we're going to go 1 times -5. And then you're going to go 1 times 2x. So you get 2x. Once you've multiplied this bottom right term by everything on top of it, you're going to go to the next term, which is 3x. So we're going to go 3x times -5 is -15x. And now you're going to notice I put it in the same column, making a stack of like terms. 3x times 2x would be 6x squared. Every time I get a new term with a higher degree, a larger exponent, I'm going to put it to the left. So this one kind of keeps working to the left a little bit, and that's what's weird for some people. Once we've multiplied all the terms together, we are going to add each stack. And we get 6x squared minus 13x minus 5. Again, you do not need to be proficient at all 4 of them, but you need to be proficient at one of them. You need to pick which method you like best. So I would like you to pause the video and try each of these and check back. All right, here are the answers for each of these 3. If you do not get the answers correct, that's okay. We will go through and talk about these problems in class, and we will do many, many of these to make sure we are getting the multiplication correct. So if you have questions, make sure you come to class ready to ask. Otherwise, have a great day, everyone.